Hello, everyone, and welcome to the Ask the Expert webinar. How can I geocode address data using SAS Viya? My name is Tiago de Souza, and I will serve as your moderator for today's event. Now, I would like to take a moment to introduce our presenter, Greg Treman. Greg is a technical training consultant on the SAS education team. He's responsible for developing and maintaining training related to SAS programming and data visualization. With all of that out of the way, why don't we turn things over to our presenter so we can get started. Greg, please take it away.
Thank you, Tiago. Welcome, everybody. I'm excited to be here and excited to talk to you about one of my favorite topics, which is geocoding address data. So let me kind of back up a little bit and provide some background here. Now, whether you're new to SAS Viya or you're an experienced visual analytics user, you're probably familiar with the idea that we can create geomaps in SAS Viya and SAS Visual Analytics. But to do so, we need some sort of geographic variable. That could be a latitude and longitude value, it could be a state name, it could be a country name. But there are a lot of times when we might have data that include some sort of geographic component, something that we want to visualize spatially that doesn't include that latitude and longitude information. So we all know that addresses have some sort of geographic spatial component, but they don't include these latitude and longitude coordinate values that we can use to create a geography data item and plot on a map. So you and I, we might be able to look at an address and we might be able to say we know where that goes, but SAS Viya can't do that out of the box. We can't directly plot an address text string without additional information, that latitude and longitude value. So to solve for that, what we need to do is we need to somehow transform this text address string into a numeric latitude and longitude value. And this process is known as geocoding. So this is where we take that text address string 123 Main Street and we turn it into these coordinate values that we can then plot on a map. And over the next hour, we're going to talk about some of the different ways that we can do that using SAS, both by leveraging our partnership with industry-leading spatial coordinate processors such as Esri, as well as other sorts of SAS tools. So I'm going to begin by talking about geocoding via our partnership with Esri. Now, there are a couple of things to be aware of as far as requirements before you can take advantage of this partnership with Esri. And most of these have to do with the admin side of things in your environment. But just to be aware, you do need to be a member of the Esri users custom group. Your organization also has to have an Esri ArcGIS online account. And then in SAS Viya, you need to enable what are known as Esri Premium services, which you can do by validating your Esri account credentials within SAS Viya. Now, it is also possible to configure to configure a single sign-on access to Esri services as of the 2023.06 release of SAS Viya. There's two steps to do that. There's some setup that needs to be done by your Esri administrator, whoever's in charge of your Esri system, as well as by your SAS administrator. Now, the general idea behind geocoding with Esri is that you take some existing CAS table that you have in SAS Viya, and you create a new output table where you add columns from Esri to the existing columns from that input CAS table. Now, something to keep in mind about doing this is that when you utilize this partnership with Esri, when you send a request to Esri to perform this geocoding, it costs Esri credits. So each time you submit a request, SAS is going to tell you how many credits that particular request will cost to complete. And it's not necessarily a one-to-one credit to dollar relationship. It depends on your own contract and relationship with Esri. So that's something that your Esri administrator can provide more information about in your own environment. But the important thing to be aware of here is that when you geocode with Esri, there is a cost to use that service, that third-party partnership with the Esri geocoding service. Now, the way this works is that when you submit a request to Esri, you say you want to take a CAS table and you want to add these latitude and longitude values to an address, it's going to use the ArcGIS World Geocoding Service. And if you've geocoded using ArcGIS Pro or ArcGIS Desktop, this is exactly the same engine behind the scenes where you're submitting address information to Esri, it's matching it with latitude and longitude coordinates, and then returning those coordinates to you and adding them to your input table. And now kind of a general rule when it comes to geocoding is that the more information you provide to the geocoding service, the better your result will be. So if you provide just a street and a state, your result may be less accurate than if you provide more components of an address. So if you provide a street, a city, a zip code, and a state. And this sort of makes sense, right? If we were to say, let's geocode the address 123 Main Street, that could be any number of different locations in any number of different cities or states across the country. But if we were to say, let's geocode the address 123 Main Street, Cary, North Carolina, then there's probably only one of those because we've supplied those additional pieces of information to the geocoding service. Now, when you do submit a request, when you do geocode via this Esri method, you're going to actually get 4 columns returned. So you're going to get a column called Esri address, a column called Esri longitude, a column called Esri latitude, and Esri score. The Esri address column is going to be the address from the ArcGIS World Geocoding Service that Esri matched to the address in the data being geocoded. So most of the time, this will either be exactly the same or very similar. So we can see in this example on the slides here, if we were geocoding the address for SAS headquarters, 100 SAS Campus Drive, Cary, North Carolina, the address that Esri will match is exactly that. And then we also have, in addition to the Esri longitude and Esri latitude, which are the coordinates of that address, we have the Esri score. And this indicates the accuracy of that returned latitude and longitude value, how well it matched the input address. And generally speaking, the more levels of geography that you provide to the geocoding service, so if you provide the address, the city, the state, the zip code, and so on, the better your score will be. Now, there's not a hard and fast rule as far as what's considered to be a good score or a perfect score. Generally speaking, though, if you have a score of 75 or above, it indicates that you have a fairly good match. That said, it's not something you want to take on blind faith. When you're doing geocoding, you do want to spot check your results. So you want to review the Esri address, the matched address, and the Esri score, and make sure that everything makes sense. That you're not think you're geocoding something in North Carolina, but got a result in New York or something. So the other thing to keep in mind when you're geocoding using this Esri partnership is that the output table that gets created is saved only as an in-memory table, only as a loaded to memory CAS table. And so what you want to do is you want to make sure that you then save that in-memory table to disk to make sure that those results are stored somewhere more permanent. The reason you want to do this is because if that in-memory table gets deleted, if you log out and it gets dropped, then you'll need to rerun that geocoding process. And remember that it does cost money. So in the interest of making sure you're optimizing your organization's Esri credits, you want to make sure that when you have the result you want, you save it and you don't have to go back and do it again. Now, there's 2 other ways that you can geocode address data using SAS. The first one that we're going to talk about is the geocode procedure, proc geocode. So the difference here between using the proc geocode, the geocode procedure, and what we just talked about, the Esri the Esri geocoding, is if you think about this idea of the Esri geocoding, it's not free, right? We pay a cost to Esri in terms of credits per request we submit, and the way that the geocoding happens is that we're passing our address data to this Esri database. It's doing the geocoding there, and then it's giving us back the results. When we use the geocode procedure, there's no additional cost. We're not paying a per use fee to wherever it's coming from. And we're doing it locally on our installation of SAS. We're not passing addresses back and forth to this third-party database. Now, at kind of a high level, the geocode procedure requires 2 input data sets. So just like with Esri or with really any other kind of geocoding, we're going to need an input data set containing the addresses, the values that we want to geocode. So information that we know is spatial, but doesn't yet have this latitude and longitude spatial coordinates assigned to it. And then we need some sort of lookup data set that contains reference variables and geographic coordinates that we can use to match locations to addresses in our input data set. And we'll see as we go through this, there are some lookup data sets that might be included with SAS and some that we kind of have to go elsewhere to create. Now, if you think about what's happening here, this is very similar to geocoding with Esri or really any other sort of geocoding. We need, in our input data set, we have some geographic variable that we want to assign latitude and longitude values for. So, that might be a zip code. Let's say we had data containing zip codes and population, and we wanted to create a map of that. In our lookup data set, we would then need information about the latitude and longitude coordinates of each zip code, and then we would match the corresponding zip codes in the input address data set and the lookup data set to do that geocoding process. Now, the exact same thing is true for addresses. If we're geocoding addresses, we will need to have some sort of lookup data set that includes the latitude and longitude values for each address that we want to geocode. So you can imagine that that's a little bit more complicated than a lookup data set of just the latitude and longitude coordinates for zip codes, because there are many more possible addresses. But the exact same process is going to happen where we match those reference values, whether it's a zip code or an address, and we add the coordinate column from the lookup data set to the input data set, and then we can then use those latitude and longitude values to create a map, a visualization of that input address data set. So there are a couple of different levels of geocoding available with proc geocode. I'm going to talk specifically about street level geocoding here, which is an address value 123 Main Street. Now, when we're using the geocode procedure, it does work for both US and Canadian addresses. It does not work globally the way some other geocoding methods do, but it does work for the US and for Canadian addresses. Now, the input data needs to have both a street address and a zip code at a minimum, but just like we saw with Esri, containing additional levels of geography will make the results better. So containing things like city, state, will increase your chances of finding a match. Now, like I said, the lookup data set for street geocoding is a little more complicated than just a table of zip codes and latitude and longitude, because there are so many different possible addresses. When you're geocoding street addresses with the geocode procedure, you do need 6 lookup datasets. You need a street matching dataset, a street segment dataset, a street coordinate dataset, a street state dataset, a street type dataset, and a street directional dataset. So I'm gonna quickly go through kind of what each of these does and what they consist of. But if you do want more information about how all of these pieces work, there's a lot of great resources in the SAS documentation that provide more information about kind of how all of these are constructed. So the street matching dataset contains street names, zip codes, things like that, state names. And the kind of key piece here is that its name needs to end with an M. And by default, if you're geocoding US addresses, the default name is going to be USM. The street segment dataset contains street type and direction suffixes and prefixes, and its name must be the same as the street matching dataset, and it must end with S. It must have the same beginning as the street matching dataset, except that it must end with S. So by default, the US name for this dataset would be USS. Then the street coordinate dataset, this contains the actual latitude and longitude values for each possible address. It needs to have the same, be stored in the same location, have the same name as the street matching and street segment dataset, except it must end with P. So the default name for US geocoding is USP. Then the street state dataset contains character names of states as well as different possible abbreviations and codes. So essentially all of the different ways that a state could be referred to. The street type dataset contains data that can be used to standardize street type suffixes and prefixes. So you might think of a name like Main Street. Street could be spelled out as street. It could be written as STR, ST, but it all is referring to the same thing. So this dataset is what's used to standardize that. And same idea for street directional. It contains street directional text strings that can be used to standardize directional suffixes and prefixes in the input data. So if you have a street that ends with east, it could be written out as east. It could be just abbreviated as E, but it's referring to the same thing. So this data set is what allows you to do that. So that's all pretty complicated. The good news is that of those 6 required data sets, 3 are already included with your SAS installation to do geocoding US or Canadian street addresses. So those last 3, the street state, street type, and street directional data sets, those are all included in the SAS help library. The street state data set is the GC state, street type, GC type, and directional GC direct. So you don't have to do anything else to create those. Those are already included in the SAS help library. You don't need to go anywhere to find them. Now you can, if you have sort of non-typical data, maybe you have some street types, street directions that aren't included in these lookup data sets, then you can go in and modify them and add additional values if you need. But you don't have to create these. You don't have to go anywhere to find them. They're already included in SAS help. Now the first 3, though, the USS, USM, and USP data sets, those are not included in your SAS installation, but they are available. So we do provide those to you. They're available for download from the SAS support website. And the way this works is that if you go to the SAS support website, you can download a zip file that includes 10 CSV files and then a SAS program called import CSV files.sas. And what this will do is it will take those 10 CSV files, it'll do some processing, and it will create that USM, USP, and USS geocoding lookup data sets. Now, these data sets are not being created. This data isn't coming from scratch from SAS. It's being created from the U.S. Census Bureau from TigerLine shapefiles. So if there is a like a specific region that you're interested in doing geocoding in, you can go to the Census Bureau, download those particular shapefiles, and then we provide some additional macro programs that will convert the TigerLine shapefiles to appropriately formatted lookup tables if you're interested in doing that as well. Now, like I said, there are other levels of geography supported by using the geocode procedure. So you can geocode at the level of the city, at the level of the zip code, at the level of the expanded zip code, the zip +4. You can also do range geocoding, which will allow you to geolocate IP addresses. And then you can do custom geocoding, which is any other level of geography that you might want to do. It works the same way for all these other levels of geography. There's certain required fields that you need to have in the input data and certain required lookup tables. If you do want more information about this, there's lots of good information in the SAS documentation. And we also have a course from SAS Education that goes into more detail about all of these methods that will provide a link to you at the end as well. So this is what the geocode procedure actually looks like. Now, the only required argument is going to be that first one, that data equals. That's going to specify the SAS dataset that contains the observations that we want to geocode. Now, there's a bunch of other optional arguments that depend on what you're geocoding, what lookup data you're using, what method you're using, all of these different things. The out equals, that's going to, of course, specify the table that we want to create, so the name of the geocoded output table. Method equals will specify the geocoding method we're using. So if we want to geocode street address data, we would specify that there. We would specify street. And then if we are geocoding street address data, we need to tell SAS where to find our lookup data sets. So those street matching, street coordinates, and so on, the ones that are not in the SAS help library. And we can do that with the lookup street equals option. So if you were geocoding street address data in the US, this would be the USM data set. And then there's lots of other possibilities. So if you have non-standard address component variable names, then you would specify that there. You know, if you had a column that contained the city name, but it was named, you know, village or something, then you would need to specify where SAS should go to find the city name in the input data in that geocode procedure as well. All right. So that's 2 out of 3 methods now. So the last one that I want to talk about is using the locate step. And this is another SAS partner. So this is a company called Locate, which is another third-party provider that specializes in address verification and enrichment, and also can provide this geocoding and address verification functionality in VIA. And this is done via a step in SAS Studio that allows you to both verify address information and add location coordinates. And so the 2 pieces here, the validate addresses, that's essentially just going to return whether or not an input address is a valid address, whether or not it exists, which can be useful for many purposes. But for our purpose, I'm more interested in that second one, that add location coordinates, which is where we go one step further. We're not just determining whether or not something is a valid address, but we're returning the latitude and longitude coordinates of it so that we can plot it on a map. Now, behind the scenes, this is using the locate API. So it's connecting via proc HTTP to the locate API and passing much the same way that we are with Esri, passing our address data there to geocode and return back the latitude and longitude values. Now, because this is a step, it can be used as part of a SAS Studio flow, which is just kind of a fancy way of saying a sequence of operations on data that we can control in a point-and-click way by connecting nodes on a canvas rather than by just writing SAS code. So nodes can represent both tables and operations that manipulate them. So as we build a flow, we connect nodes, and SAS Studio behind the scenes generates the SAS code necessary to perform those operations on those specified tables without us having to actually go and write the code. Now, just like we saw with Esri geocoding and with the proc geocode geocoding, the input table that we are doing the geocoding to must meet some minimum requirements. So there's certain variables that it has to have. It needs to have, at a minimum, a street address and a country. But like we saw with all of the other sorts of geocoding as well, having additional variables does make it more accurate, more likely to return a better result. So, adding things like the postal code or the city or the state can all result in better outcomes, better matching if you do have access to that information in your data. Now, there's a couple of other things that you need to have set up in order to do this. So the biggest piece is that because this is using a third-party provider, you need to have a locate key that allows you to access the API. Now, if you have a locate account, you can get this from the locate website. But just like we saw with Esri, accessing that API, calling this third-party resource to geocode or to validate addresses, it does incur a cost, and that cost will be determined by your relationship with locate. So that's something that you would need to figure out based on what sort of contract or account you have with them. Now, because it does incur a cost to run this geocoding against the API, it's a good idea to kind of do some prep work first. So you can, in the step in your SAS Studio flow, there is a test mode that allows you to validate your flow and check the log, see if there's any issues before you actually call the API. And so that can help you avoid unnecessarily creating costs for yourself if you might have an error somewhere. The other thing is that locate requires country values be in ISO 2 or 3 character codes. And if your data isn't already structured in that way, the step has a built-in option that allows you to automatically standardize country names before calling the API. So you don't have to worry about what format country names may be in your data. So if you look at the example on the screen here, you can see that this would take, no matter how the country name was written, whether it was fully spelled out, whether it was already standardized to a particular 2 or 3 character abbreviation, it would take care of that piece for you. So it's not something that you would have to worry about. All right, so I've kind of talked about those 3 different methods of geocoding. So you might be wondering, how do you decide which one to use? And the answer is really that it depends. It depends on what relationships you may already have with these geocoding providers, what your programming experience may be, what budget you have, what volume of data you might be geocoding, what sort of accuracy you require, where the data is located, all of these sorts of things. So it's not that there is one method that's head and shoulders above the rest. It's that it's useful to be familiar with all three because depending on your particular circumstances and goals, different options may be more effective, more budget friendly, more accurate than others. All right. So with all of that background out of the way, what I'd like to do now is switch over to a demonstration so I can show you what this actually looks like sort of in the wild. So let me see if I can share my screen here. And what I'm going to do is walk through some examples of all of these different methods so you can get a sense for how they work and what they look like. So I'm going to start by showing you what this Esri geocoding looks like. So I'm already in SAS Visual Analytics here. And I've got a report that I'm going to open. And for the purposes of this demonstration, we're going to be geocoding a pretty small, pretty simple table, just so we can get a feel for what it looks like. But this is some address data for post offices in the state of Oklahoma. So you can see this is our input table. This is the table that we want to geocode. We have the address, we have the city in which it's located, we have the state, and we have the country. And I would like to eventually be able to just plot a simple coordinate map. So I could drop some dots on a map and see where these are located. And I'm going to do that using Esri. Now, the way I access the Esri geocoding feature in SAS Viya is going to be in SAS Data Explorer. So I can access that by coming up to the top left, going to the Applications menu and choosing Manage Data. And this would be the same location where you go to import data. So I'm here, I'm in SAS Data Explorer, and I'm going to go to the Import tab. And you see at the bottom of the tab, there's a section called Esri. And here I have two options, GeoEnrichment and GeoCode. GeoEnrichment is another thing that's supported with our partnership with Esri, where you can add additional information to a table that's not just latitude and longitude, but all sorts of other demographic and other characteristic information. But what I'm going to do is I'm going to use this GeoCode option. Now, before I do that, though, I want to show you what sort of the setup piece that I need to take care of is. So remember, I need to have validated my Esri ArcGIS account credentials with SAS Viya in order to be able to access this. And I can double check on that by coming up to the top right, clicking on my account profile, clicking Settings, and then you see there's a section called Geographic Mapping. If I click on that, let me come back to SAS Visual Analytics, actually, where I have already logged in. And then in the geographic mapping section, I can see that I have accepted the Esri ArcGIS online terms and conditions, and I've validated my account credentials. So I'm going to come back to this import tab, and it looks like I have somehow gotten logged out. So give me like 2 seconds here, and I will get that resolved. So now that I am signed in to my ArcGIS Online account, I'm going to click that geocode option again. And now what we'll see is I have the option to choose what table I want to geocode. And here it will show you all of the in-memory CAS tables that you have. So the table that I am going to geocode is this OK Post Office Small. That's the table that was from my Visual Analytics report. So I'm going to select that. I'm going to click OK. And then it will bring me this Configure Geocode Settings page. And there's 2 steps here. So the first step is where I will select the columns that I want to use to geocode the input data, and then step 2 as well, I'll configure options that I want for my output data. So here I'm going to first start by selecting the address and the city columns from my input data. And you see at the bottom, it builds a sample address here. So that's the address that's going to be used to do the geocoding. And if I hit that test button, it will run just that sample address to the Esri geocoding service, and it'll return the score. And it looks like in this case, it's returning a score of 100. But remember, it is always better to pass more levels of geography to the geocoding provider. So I'm also going to select state and zip, and I'll test it again just to make sure. And it looks like I'm still getting a score of 100. So now that I've configured the geocoding columns that I want to provide, I'm going to move on to step 2 where I'll configure the output file options. So here I can do things like specify the name. Now the default name is always going to be the name of the input table underscore geocode. And I'm also can specify where I want it to be stored. In this case, I'm going to leave that as the default public CASLab. And I can choose whether or not I want to replace the file if it already exists. Just in case, I'm going to choose that I do want to replace it. Now, once I've made all of my selections, all of my configurations here, I'm going to go ahead and hit that import item button. And then I'll get a little pop-up here, and this is going to tell me before I send this off to Esri, it's going to tell me how much it'll cost. And because we have a pretty small table here, we're only geocoding, I think, like 20 rows, it's going to tell me that it will cost 0.8 credits. And there's not a particular dollar value on that. Again, that will depend on what your particular relationship with Esri is. But it's a good idea to be mindful of this as you go through and use the Esri geocoding feature. I'll go ahead and click yes. And then it will perform that geocoding. It'll send that data to Esri, and it'll send back those latitude and longitude values. And I can see that it looks like it was successful here. I've got a little green check mark in the tab on the left. So now that it has been successfully geocoded and loaded into CAS, I'm going to switch back to SAS Visual Analytics. And I'm going to add that new geocoded table to this report, which I can do by coming up over here on the left to the Data tab, and then saying I want to add data. And then it will show me all of the data that's been loaded to memory. And so I'm going to select that OK Post Office small geocode, which is the result of that import that we just performed in SAS Data Explorer. So I'll click Add. And then I can see in the Data tab, I can see all of those new columns: Esri score, Esri longitude, Esri latitude, and Esri address. But I want to compare this to the values in the input table so I can see how my geocoding performed. So what I'm going to do is I'm going to create another list table here, and I'm going to assign all of those values to it so I can look at them side by side. So I'll say I want to look at the address, city, state, and zip, which were all the values in my input table, and I want to compare them to my Esri address, which is the matched address. And then I also want to look at the Esri score and the Esri latitude and longitude. And I'll hit apply, and then I'll see all of that here. And there's a couple of things I want to point out. So it looks like all of our Esri scores are really good, mostly 100, a couple slightly less than 100. And if we look at them, we can kind of see what's going on. So it looks like this first row has an Esri score of like 98.8. And we can see that there's one slight difference between the input address and the matched Esri address. It looks like the input address was 104 North Main Street, and the Esri matched address didn't include that North prefix. It was just 104 Main Street. But like I said, general rule, it's a good idea to kind of spot check these, but this all looks really good. So what I'm going to do now is kind of that last step, that goal from geocoding, which is to be able to visualize these addresses on a map. So I can come back to the Data tab, and I can say I want to create a geography data item. So I'm going to take that input data, and I'm going to change its classification to geography. And here I can say, let's try that again. Okay, finish loading. I can say I want to do that based on the latitude and longitude values in my data, and those are those latitude and longitude values that I just got using the Esri geocoding. So for the latitude, I can choose the Esri latitude, and for longitude, I can choose the Esri longitude. And it'll on the right, it'll tell me that found a map. It matched 100% of those, 100% mapped. I can see on this little preview map that it looks like they're in the state of Oklahoma. So I'll hit OK. And I'll come over here to the coordinate map tab and just go ahead and throw those points onto the map. And there I have those text address values now geolocated and placed on a map. So that's Esri geocoding. I want to then, let me close this report. I don't need to save it or anything. I want to show you what proc geocode looks like. So let me come over here to SAS Studio, and I've got a program here called proc geocode that I'm going to walk through with you. Now, the first thing that I need to do is I need to make sure that I have the correct library set up. So I'm going to be using data that's in the public CASLib, so I'm going to assign a libref to that. And then I also have my lookup data stored in this location, and I want to create a library pointing to that as well. So I'll run these two libname statements. And then I'll see here is my public CASLib that has my OK Post Office small table in it. And here is my lookup table that has that USM, USP, and USS tables, those three required lookup tables for proc geocode. Then I have my proc geocode procedure itself here, and this is almost complete. I've said that I want to geocode my OK Post Office small table, so very similar to what we just did in the last example. And I want to create a new table called OK Post Geocode. Now I need to specify the method, and so here I'm going to specify the method being street, because I want to geocode this street address data. Now there's other levels of geocoding available as well. I could geocode at the zip level. I could geocode at the city level, all of those other ones that I mentioned. But in this case, we're geocoding street addresses. And then I need to tell SAS where to find my lookup data. So those three lookup tables that aren't in the SAS help library, I need to specify where to find those. And those are going to be in this lookup library. So I'm going to say that the lookup table, the lookup street matching table, is in the lookup USM. And I only need to specify that because they're all in the same location and they all have those matching names, USM, USP, USS. So once I've completed that geocode procedure, I'm going to highlight that and run it. And I'll get some information here. So it'll tell me, it was looking for the street lookup data here. Here's where it found other data. We geocoded 20 rows and so on. And it found 20 matches, so no issues there. And if I click on the output data tab, I can see, well, we'll go through all this in a second, but I can see that I do have those X and Y coordinate values, those latitude and longitude values that I'll be able to use to create a map. I also have this M address, which will be the matched address from the lookup data set, and all of the components there, the matched city, the matched state, the matched zip code. And then I have some information about how it did the match. So this _matched tells me that it found a street level match. If it wasn't able to find a street level match, if it found like a zip code level match, it would tell me that here as well. And then this notes column provides information about how the match score was calculated. So each one of these little codes here provides information about what sort of match it would found: matched address, matched zip code, matched end name of street, various things like that. And those values are used to calculate the score. So much like we saw with Esri, there's a score of how good the match is, how well it matches the input address. Now, the last thing I need to do is, in order for me to use this table in Visual Analytics, I need to promote it to a global scope table. So that's what this last piece of code does. So I'll hit run there. And then I'll come back to SAS Visual Analytics. And I have another report to take a look at. Now, this is exactly the same thing we saw before. We have our address, our city, our state, our zip, and our country. But I want to compare the results of my geocode procedure. So I'm going to go ahead and add that as well. And I see here there's that newly created OKPost geocode table. So I'll go ahead and add that to my report. And then just like I did in the last example, I'm going to look at the geocoded values and the original values side by side. So I'll say assign data. And then I want to look at the address, the matched address, the city, the matched city, the state, the matched state, and the score. And if I look at this, we can see that our scores are mostly pretty good. They're all above 75. Got some in the 80s, some in the 90s, and we can see that not everything is a perfect match. This first row that has a score of 82 looks like it didn't quite match the number of the address. The input address was 104, and the matched address was 700. But they're all in the same city, all in the same state, and all look like they're if not the exact address, very close to the address. So these generally performed pretty well. Again, you will want to spot check these results when you perform this sort of geocoding, whether it's using Proc Geocode or Esri or anything else. Now, just like with the last example, the reason I'm doing this is that I want to create a map. So I can go to the data tab and I can turn this into a geography data item. And again, I can use the latitude and longitude that I calculated using the geocode procedure. So for the latitude, I'll choose my geocoded latitude, and for the longitude, I'll choose my geocoded longitude. And again, I'll see that all those points appear to be in Oklahoma, which is a good sign. So I'll click OK. And then I can throw that on to a map. And we'll get very similar results to the last example, those 20 points plotted on a map. Now, the last thing that I want to show you quickly, so I'll try to leave some time here for questions as well, is using the locate procedure. Now, this uses a SAS Studio flow, which is this point-and-click programming interface. So I'm going to start with that same OK Post Office small table. And then I'm going to add this step that will allow me to use this locate geocoding API, which I can find in the left on the Steps tab. There's a bunch of different options here for different ways that you can interact and manipulate data. If you scroll down, there is an enrichment option. And you see that there's a step here called Verify and Geocode Addresses Locate. So that's what I'm going to choose, and I'll just drag it onto the canvas. And then this is pretty intuitive. I want to have this OK Post Office small act as the input table. So I'll click on it and drag an arrow to the input node on this Verify and Geocode Address step. And then I need to specify the fields that I want to use for address verification. So at a minimum, I need country and address. So I will click on the little add button there, and I'll select the country column from the input table, and I'll click OK. And same thing for address. I'll click address, and I'll choose the address column, and I'll click OK. And then it's always a good idea to add additional values if you have them. So I'll also add a city. and a state. And then I want to specify what table should be created. So I'll click on this add button here at the top, and I'll say I want to add a table. And then I can connect this to the output node, and I can specify where I want to put this. So I'll put this in the public CasLib, and I'll call it OK post locate. And I'll say OK. Then the last thing that I need to do is on that geocode tab, I can specify that I want to geocode the address. If I don't select that, then it will not geocode the addresses. It will just verify that they exist. And then I can also say whether or not I want to do that ISO standardization. So if I have country names written out, this will convert them to those 2 or 3 character ISO names. Then I also need to specify a locate key here. And so this is what will allow me to access that API and incur that cost. Now, in the interest of time here, I'm not actually going to finish running this. What I'm going to do is I'm going to switch back over to SAS Visual Analytics, and I'm just going to show you what the results would look like. So let me open up my last report here. And this is the exact same data that we've seen before. What I'm going to do here is add and this was a pre-prepared version in case we ran a little long here, of this OK small locate. So that's going to be the results of this locate step. So I'll click that, and I'll add it. And you see that we get a ton of new columns here. So these are all of the different possible values that locate can look to match. And then things that begin with DM are the values from the input table. But like we saw before, I want to compare the input and the geocoded result so we can see kind of how this works. So I'm going to, in this list table, I'm going to add my input address, the matched address, the input. Let me see, where do we have it here? I'm going to look at the geo accuracy and the geo distance field, and that'll give me some information about how the geocoding worked. And then I'll take a look at this. And so you can see the matched address here and the input address. So we've got 104 North Main, 104 North Main, so that all looks pretty good. Now the 2 values that let us judge how the geocoding worked are the geo accuracy and the geo distance. The geo accuracy contains a code basically indicating how well locate was able to match an input address. Most of these are P4, which is the highest level of accuracy, and it means that it found an individual matching address at the specific premise level. We do have a couple values, I4, and essentially what this means is that it interpolated a range of values. So it doesn't have the latitude and longitude values for that specific address, but rather it's sort of averaging based on the address between a certain range of values. So it's still very accurate, but not quite as accurate as P4. The geodistance field is the radius of possible difference between the input address and the return coordinates. So most of these are 0, meaning that it's spot on, it's exactly right. Whereas a couple of them, the ones that have that geo accuracy of I4, have a geodistance value of 5, meaning that the radius of possible difference between the input address and the returned address is up to 5 meters. But in either case, both are still quite accurate. So the last step would be just to convert that to a geography data item using those geocoded latitude and longitude values, and it'll appear to be in Oklahoma again, and add it to the map. And we'll see that we get very similar results as the last couple of examples, where we have these text address strings that have now been converted to numeric latitude and longitude coordinates that we can visualize on a map. All right, I know we're almost at time here, but let me hand it back over to you, Tiago.
Before we go, I do have a couple of reminders here. First, if you're looking for an in-person opportunity to connect with others, it's the SaaS Innovate 2025 edition. It's our premier conference for business leaders, technical users, and SaaS partners. We will have inspiring keynote speakers, practical hands-on workshops, insightful breakout sessions, and much, much more. It's all happening from May 6th through May 9th in Orlando, Florida. And you can visit saas.com/innovate to learn more and to register. And secondly, I'd like to remind you about the 2025 SaaS Customer Recognition Awards. If you've accomplished something amazing with SaaS software, we want to hear about it. Please submit your story for a chance to win a trip to SaaS Innovate, where first place winners will be announced live. You can read the rules and submit your entry at saas.com/CRA. On behalf of myself, Greg, and all of SaaS, we really hope they enjoyed today's webinar. Thank you all, and have a great rest of your day.